Now let's see how we can calculate the acceleration of this motion. This angle and this angle are equal. Then this is the pulley. Now we are looking at, let's look at it this way. If the direction of the acceleration is this direction, this is the tension, this is also the tension. The tension are the same. The tension on both strings at this side and at this side are equal. Then if you resolve based on this plane, we are going to have m1g sine theta. Likewise here, since the angle the same, this is m2g sine theta. Now if you consider this motion, it means if moving this way, that means this force is greater than this tension. Now m2g sine theta minus tension T is going to give us m2a. That is the resultant force. This is equation 1. Then from this side, if the direction of motion is moving toward this side, this tension is greater than this m1g sine theta, because this is going to overcome this force. We now have tension minus m1g sine theta is equal to m1a. This is equation 2, which is the resultant force of the second mass or second body mass m1. Solving the two equations simultaneously. Let's say equation 1 plus equation 2. That will give us, if we sum these two, this will cancel this. We now have m2g sine theta minus m1g sine theta is equal to m2a plus m1a. From the equation, we have m2g sine theta minus m1g sine theta equals to m2 multiplied by acceleration plus m1 multiplied by acceleration. Now in this equation, we need to factorize the equation. From here we see g sine theta is common. This is also g sine theta, so we factorize g sine theta. G sine theta multiplied by m2 minus m1 equals, acceleration is constant here, so we have to factorize it. Acceleration multiplied by m2 plus m1. So in order to determine acceleration, we need to divide both sides by m2 plus m1 over m2 plus m1 over m2 plus m1. This will remove this. Therefore, acceleration equals g sine theta multiplied by m2 minus m1 over m2 plus m1. Now with this equation, we have determined the acceleration of the body. You can also use it to calculate the tension. If we have calculated the acceleration, or now that the acceleration is known, tension can also be calculated. We can make tension subject to the formula from equation 1 or equation 2. Maybe from equation 2, which is tension minus m1g sine theta equals to m1a. Now we can make tension subject to the formula. That will be m1a plus m1g sine theta. Then tension will now equals to m1 is common, acceleration plus g sine theta. With this, we have determined the tension on the string. The tension on the string are equal. If we have calculated our acceleration, substitute the acceleration into this formula, we calculate our tension. This is how to determine the acceleration and tension on string when we are having motion of connected bodies from this figure.